what I want to talk about is an example app that lets you start building Node applications as a kind of a getting started guide. So there's a lot of stuff about Node. There's a lot of stuff that you don't need initially. Streams are a really good example. You can get very far, and I did, without streams. And it's only once you've got a foundation, once you know how to build simple web apps and that sort of stuff, that you can start looking at all the other cool stuff that Node provides. And I believe one of the best ways to learn is to have example code, an example code that is simple and relatively concise and kind of makes sense. So what I put together was an app that's kind of inspired by these meetups and these conferences. And essentially, it's an app that encourages networking. So the way that it's a game, and the way that you win the game is by networking. So if you've tried it out, you log in to Twitter, gets your Twitter account, avatar, that sort of stuff, and it assigns you a playing card, and it assigns you a team. So in my case, when I logged in, it assigned me to the playing border team and gave me 6 diamonds. And what I do with that then is I have to go out and find everybody else who's on the playing border team. If I look at the team, you can see there's 3 other people who have registered with the app and have been randomly assigned to the team. You can see that I've managed to connect with one of them, this one over here.
We're not seeing any of them.
You're not seeing? Just, you're in. There you see it. Very good. Okay, so the idea is, you see the list of people in your team. You've already didn't see this page either, right? It's the home page which you log in. It tells you which team you are on and the card that you can sign in. You see the list of people in your team, and you have to go up and try and guess which card they've been assigned. Of course, much easier to actually go to the person and talk to them. And if you do that, the whole idea is that over time, your team gets more points. So the team that has the most points is the team where people have networked the most, that's how you win. So the purpose of this app is not to be a great game or not to revolutionize conferences. It's to encapsulate a simple set of business logic. So it's done as a mobile app. It's done using the Essential framework, so it will run on mobile. But it's also designed to have a really, really simple business logic. So you log into Twitter, it assigns you a team, it assigns you a card. You then get a list of the other people in your team. If you select one of them, you're either already connected to them and it shows you their details. Or if you're not connected, it shows you the card selection, and once you have the right card, it's connected up. And finally, it has a leaderboard that shows the current teams and what their scores are. So those are all really simple business logic operations. It's also a simple web app. So there's no streams, there's no fancy stuff. You're essentially just serving up JSON requests. So the code for this app is designed to be extremely simple. Almost all Node.js apps have this convention that the thing that runs, the web server that runs, is called app.js. And you start it up by saying node app.js. And in this case, this is what the app.js that runs this app looks like. And as with most Node apps, one thing about it is it's 50 lines of code. Right, so if you come from a world where you're putting together Java servers or C# or even Ruby on Rails, the code volume is so low, it really reduces the amount of bugs and the amount of work that you have to do. So what I'm going to do is step through this code, which sets up the app. And I'm going to look at how the business logic is implemented. So the first thing that I'm doing, Dominic talked about requires, is requiring you all the different things that I need. The first thing that you need is configuration, because you're going to connect to the database. And the easiest way to do that is to put your configuration into a module itself. So you can see here I'm loading up the config.my.js file, which happens to be a file that I have in the same folder. And it's just JSON data. It's a module that exports, and then I just put in whatever data I like. And if you're feeling malicious, you can go in the database now. But it's very, very simple to access, because once I require that in, then I can say config.auth, config.mongo, config.whatever, and I've just got my data. There's nothing to worry about. The next thing I'm using is Express. Express is kind of it's kind of the most common web server. If any of you have used Node or other tutorials, you probably use Express. It's a very simple web server. You just tell it where your static files are, and it will give you a website. The next thing I'm using is something that I've introduced before at this meetup and a couple of other places, is Business Logic Framework. So one of the really cool things about a framework like Django or Ruby on Rails is that it gives you an obvious place to put your business logic. And when somebody else comes along to do maintenance work, or when you have a larger team, finding the place in the code base where something happens is easy, because you go and look for it in controllers. So this is essentially riffing on the controller idea, but doing it for Node.js and divorcing it from the web servers, which can use it in more contexts. But all those things that I talked about, loading up the list of people in your team, registering with Twitter, connecting with someone, generating the list for the leaderboard, those are all things that are work that you can do in controllers. And when you ask yourself the question as a maintenance coder, where do I find the code that generates the leaderboard, it should be obvious using the framework where you go. And you'll see that in a minute. So this framework gives you the ability to connect to a database and exposes a very simple object relation mapping layer. And it has a couple of plugins that look after things like user logins and authentication, all that sort of stuff, so you don't have to worry about how logging into Twitter works or any of that sort of stuff. But the plugin framework also lets you define your business logic easily. So in these couple of lines of code here, I'm pulling in the different plugins that I need. I'm going to use Mongo for my data store, and that's what it's going to layer the ORM on top of. I'm going to have user accounts, and then I'm going to have authentication. So user accounts are not the same thing as authentication. Authentication is logging in using username and password, or logging in with Twitter. It's different from managing your users, so they're separate. They're separate plugins. And finally, I'm putting in my own plugin, the Well plugin, which has my own business logic. Once everything's set up, I pass in a callback to the ready function. And I need to do that because I have to connect to Mongo. In this case, for the app, I'm actually using mongohq.com. So the database is actually running somewhere in California. So it takes about 2 or 3 seconds to connect. In fact, if I run it locally, just right up here, you can see it takes a couple of seconds and then it kicks in. And you can see there's some logging output given to you by this Scenic framework telling you what's happening. So once I've logged in, I'm going to ignore these lines of code for a minute. We'll come back to those. I want to set up my Express app. And this is completely standard Express stuff. Express is also plugin based, and it has a whole bunch of plugins that give you access to cookies and JSON data and static files and all that sort of stuff, and HTTP sessions, all that sort of thing. And you just say app.use, the same way you say Seneca.use, and pull them all in. The only interesting thing to note here is that the business logic framework integrates with the web server by exposing a piece of middleware. So the way that Express works is it uses layers of middleware. So all of these things offer a very simple function with the signature request, response, and next. And when a HTTP request comes in, it just falls down through the layers. And when it finds a function that likes what it sees, that function does the work. Sometimes functions do work, but they're not done yet, and they pass things on by calling the next function. So in this case, when a HTTP request comes in, the first thing that's going to happen is the cookie parser is going to look for cookies. The query and body parser are going to see are there any input coming in. Method override handles a situation where you can only do gets and posts, and you need to simulate puts and things like that. JSON looks to see if you did a post and if the body content is actually JSON, it can be parsed if you put in a MIME type of application JSON. And when the session puts a session cookie in and lets us store session data in the normal way. And finally, the last two lines, Seneca, of course, has to intercept the requests to do the Twitter callbacks, all that sort of stuff. And finally, the static module is what serves up the index.html and the JavaScript and all that sort of stuff. So that sets up our web server. We still have to worry about our business logic. That lives in the well.js file, which is the place where we put all of the business logic, the boring stuff that our application wants to do. If you want to get the background on this code and deep documentation, there is a website that kind of goes into all the different details about it. I'm going to gloss through it pretty quickly and maybe follow one of the pieces of business logic so you can kind of see what's happening. One of the things that we're going to do is register all these pieces of business logic. And the way that the framework works is by pattern matching. So it doesn't create an API for you as such. What it does is it says, give me JSON documents. If I like the look of them, I might do something with them. So you might send it a JSON document that says, register this user. Or you might send it a JSON document that says, load this list from the database. In our case, we have a couple of things that the app needs to do. When you log in first, it needs to figure out who you are, what team you're in, that sort of stuff. The who am I piece of business logic looks after that. The leader gets the leaderboard. You need to see who the members of your team are. If you're connecting with someone, that's what the well piece of business logic does. And there's a couple of other ones that are used by system administrators, let's say, creating an event, that sort of thing. So if we look at, for example, the leader logic, it's relatively straightforward to follow. So we want to get the list of teams, and we want to return that to the user. So this is a HTTP JSON request, doing a get, and I return a JSON object with the list in. The arguments that are passed in are provided externally, but in this case, we're saying, well, we need to know what event we're talking about here. So that's got to be one of the arguments. We have a team entity, which is provided by the ORM layer. I'm just going to list all of the teams that match this event. And I'm using a standard Node.js callback pattern. We go through the list of teams and we construct a reply. We don't want to return all the data from the teams. All we're doing is generating a nice list with just the data we need. The underscore is the underscore library, which provides a whole bunch of functional things for JavaScript, like mapping here, which generates a list from the function that's called for each item in the list. And when I'm finished, I just send back the teams. Of course, you need to say that this particular piece of logic is connected up to a particular HTTP endpoint. And the way you do that is fairly straightforward. So that happens here. I just provide a